Hello everyone, welcome back. So in continuation to our previous video, what we discussed till now is we have understood what a load balancer is, and we understood how it is different from a proxy. What are forward proxies? What are reverse proxies? Now in continuation, uh, we will understand how we can reduce the load to our server. What are so the problem statement is, let's say your database operations is very expensive, and you want to reduce the cost of running cost of database. Also you want to reduce the load on your server as a whole. So how would you achieve that? So that is where the concept of caching comes. Now in this session we will discuss about caching. So caching, when you get introduced to the concept of caching, it can be implemented at multiple places. So to start with, it can be implemented at the CPU level also. So when your code is running onto some machine, and it is utilizing some CPUs, at that place the system introduces some memory caches. That is one kind of caching. Just to give you a picture where all the caching can be implemented to reduce the load. So this you don't have to do. This is already taken care by the processors. Next thing is DB caching, which is database caching. So next level of caching you can introduce is at the database level. So you need to understand what all static data are there in your database which does not change very frequently. In that case, you can introduce caching. You can say that whenever this certain query comes, do not execute the query on the database server, rather just use this data. And over the time, let's say your data, that static data changes, you update your cache. Next thing is server level caching. So if you see this whole server, you can introduce caching at this level. You can introduce caching at each machines. We call that caching at service level. Second thing is you can introduce caching in a distributed cache. You can use any third party tool to keep your logic of caching over there. For example, Redis. So this is third type of caching, which is server level. Another type of caching you can do is at the client side also, which is client level caching. This level of caching is done at the browser level as well as at the mobile application level. So we will discuss more about this in another session, and along with CDN. So the fifth type of caching that we can introduce in our system to reduce the load is CDN level, which is content delivery network. We will have a detailed discussion about CDN and client level caching, but this particular session is all about the server level caching. So now you can see there is a cache, distributed cache, or a third party cache server running on the cloud, and all our services are referring to that particular cache. So this is what I was talking about when I said distributed cache. We will discuss more about it. Before that, if you see, there is a cache component introduced at all the service level. This is kind of cache which you handle in your code. Like let's say your code is running on Kubernetes, and your services, uh, for example, you are running one product management service, and uh, that service is trying to use some data which can be cached. So you introduce that cache at the app level or the service level itself, where you keep that data until it is valid. For example, I have a token which I don't want to fetch again and again. And that token, so token can be a bad example, but that token I can keep in the cache. Whenever the request comes for that period of time, let's say my token is valid for 35 minutes. So for 35 minutes, that token will be valid and will be there inside cache. And right after the time lapses and the token expires, the expired token itself will be there in the cache until a new request comes. So whenever a new request comes, it sees that token is expired, fetches from the cache and sees that the token is expired. Then it fetches the new token and update the cache. So this is one example how you can manage the cache at the service level itself. But when you scale out, and when you scale out, you have introduced a cache server which is distributed in nature. In that case, you need to decide what kind of strategies you will use to read and write the data inside that cache. So there are certain strategies which is already defined for write operations as well as read operations. So whenever you write something in the cache, you use either of these available options. First one is write through uh, strategy. In this strategy, what happens is whenever you write something, you send a request to the application to write something. The application writes that particular data in the cache and immediately it gets written to the DB. So this kind of strategy is called write through, where we are writing through the cache. Second one is write around. The application writes the data to the database and keeps it there. And when there is a read operation for the same data, the database sends the data to the application, and application keeps one copy to the cache, and user gets the data of that copy. Now cache is updated. So this strategy is called write around strategy. Third one is write back strategy. Write back is whenever you send the data to be written, whenever you initiate a transaction, it gets written to the cache first, and eventually over time it gets updated in the database. So these are the write operations. Similarly, when someone refers, like when a read request comes to the server, there are certain read operation strategies. First one is read through strategy, where we are reading through the cache. Now let's say I referred to some data, and that data is cached in the cache server. Then I'll immediately get the data. But let's say I don't have that data in the cache. There will be a cache miss. And in that case, the cache server will read it from the database and update itself with the data. Now, next, whenever the read operation comes, there won't be any cache miss. So, this kind of strategy we call read through strategy. And finally, cache aside read operation strategy. In this strategy, Whenever a read operation comes to the cache, if the data is there, it will return it. And if the data is not there, it sends a notification that data is not there. The application calls the database and gets the data and updates the cache so that user can get the data. So this is cache aside. The difference between read through and cache aside is the cache over here calls to the database, and in cache aside, application does the all the operations. There is no communication between cache and the database. Now moving forward, we discussed about strategies that we use to read and write in a cache. Now going forward, we have some algorithms like least recently used, least frequently used, first in, first out. There are a lot more algorithms that are used to implement cache. Now, why do we need these algorithms? Because we want to optimize the data operations in a cache. Now, transactions in a cache are very frequent, and transactions in cache should be optimized. In that case, what we do is we take the help of cache algorithms. Now, I'll have a separate video explaining some of the cache algorithms, but this video we need to understand that where the cache lies, how cache helps in reducing the load to the database servers. Now, we discussed about write and read strategies. Next thing we want to discuss over here is earlier we were honoring all the transactions directly to the database. Like whenever there is a new read operation, it was directly going without cache, it was directly going to the database, and we were executing some query on the database and sending the response back. So time taken was also higher over here because query execution takes some time. Along with that, there was certain load on database. So let's say your service becomes more popular and you have not implemented caching. In that case, there will be certain cost while running the database server. Also, there will be high chances of failure because the load is directly coming from application to your database. So cache helps in reducing these problems. Cache helps in reducing the latency. Also, it helps in keeping your system stable. Now, next thing we will discuss is CDN. How CDN helps in reducing the load to the service. How CDN helps in reducing latency, and what is client level caching. Thank you for watching.